Now, in this part 2, on the topic approaches to design controlled release dosage form based on different mechanisms. Here, one by one mechanisms we'll going to discuss and give you a brief idea about those mechanisms. First one is diffusion control system. As earlier in the classification part I have shown you. So basically diffusion process shows the movement of the drug molecules from the region of higher concentration to one lower concentration. The flux of the drug is denoted as J, means in amount, by the area of time. Across the membrane, this movement of drug across the membrane in the direction of decreasing concentrations given by Fick's first law, which is the basis of diffusion control release. Here J equals to minus dc by dx. Here d is the diffusion coefficient in area by time. dc by dx equals to change in the concentration, and x is the distance. Means based on the concentration, based on the time, based on the concentration differences, how movement of drug taken place is explained by this equation. Now, as I have already told earlier, it is further classified into two types: reservoir type systems and matrix type systems. In reservoir type system, a water insoluble polymeric material encloses a core of drug which control the release rate of the drug. Drug will partition into the membrane and exchange with the fluid surrounding of the particles. In matrix type of system, a solid drug is homogeneously dispersed in the insoluble matrix, and the rate of release of drug is depend on the rate of drug diffusion and not on the rate of solid dissolutions. So the entire systems is based on the diffusion mechanism. Following the diffusion mechanism, the movement take place. Now coming to the next part, that is called dissolution control release. Drug having high aqueous solubility and dissolution rate shows challenge in controlling their dissolution rate. Dissolution control release can be obtained by slowing the dissolution rate of drug in GI medium, incorporating the drug in an insoluble polymer, and coating the drug particle or granules with a polymeric material of various thickness. This is the overall concept. So further classification is encapsulation, dissolution control release. The drug particles are coated or encapsulated by microemulsification techniques with slow dissolving material like cellulose, polyethylene glycol. So different waxes are there that can be used to coat the drug material which is having high solubility. So to maintain the dissolution rate, we have to coat it out all those particles with insoluble polymers or insoluble materials. In the matrix type dissolution control, the matrix system of the drug is homogeneously dispersed throughout the area at a rate controlling medium. They employ waxes such as beeswax, carnauba wax. This kind of methods can be used for dissolution control release system. Now in the next part, dissolution and diffusion control, both the things simultaneously going to happen. The dark core is enclosed in a partially soluble membrane. Pores are those created due to the dissolution of part of membrane which permit the entry of aqueous medium into the core, hence the drug comes out. So by this way drug movement can take place, but still the concentration gradient in this case is going to play a vital role. That's why we are uh, name this particular mechanism is as dissolution and diffusion controlled release. Next, osmotically controlled release system. From the name itself, you can able to assess one thing, that this system are fabricated by encapsulated and osmotic drug core containing osmotic active drug or drug substances. Here, by using the osmotic pressure differences, drug release can be controlled using the osmotic layer movements. Ion exchange part, this system is designed to provide controlled release of an ionic or ionizable drugs. It is prepared by first absorbing an ionized drug onto the ion exchange resin granules, dissolutions and diffusion of the dissolved drug out of the system. So specific type of system it is, and it is also can be used for as an approach of controlled release drug delivery systems. So we are going to end this session over here, and we are going to move on our third part